What's up, Colton?
What's up, Dad?
Oh, man.
Yeah.
I love having you around.
Yeah, it's good. It's been a good 2 weeks being back home for a bit.
Yeah, and you're at Rise. What are they calling it? Is it Tech 2? It's career training? I've heard Stephen was going over a couple of different terms.
Utility solar technician level 2 training.
Okay.
Yeah.
Well, what'd you learn in school this week?
Oh man, it's everything. It's everything from DC health, reading schematics, into all sorts of troubleshooting, advanced inverter component replacement, and understanding parts, MVTs, everything you could run it into on a utility scale solar site.
Yeah? Worth your time?
I think worth a lot more of my time. Yeah. No, it's been great. I went to the level 1 training in May, I believe, of 24, just this last May. And I learned more than I did in my 5 months in the field to that point, or from anybody else. And this 2 weeks, I've quadrupled my knowledge.
Mm-hmm.
They're doing something special over there. It's very good. The way that they lay out the classroom training combined with, they've got an incredible lab with 4 utility scale SMA inverters and one new one, an ABB Ultra 1500. Their lab is fantastic. They've got an MVT, a recombiner, everything you could need to learn how to work on a solar site. They've even got an oscillating PV module stand. It's very cool.
I am stoked about your passion for this industry. I didn't think it was ever going to happen.
No, me neither.
No.
No, me neither.
No, I think, what did I hear most of those years? I don't think so, Dad.
No.
I don't think so, Dad.
I'm going to go do something else.
Mm-hmm. 4 years at UC Santa Barbara.
Yep.
No, I don't think so, Dad.
No, that was 4 years and 6 figures later, and I got a shiny piece of paper that's collecting dust in your attic now, I think.
You better take that 6-figure paper out and hang it somewhere.
Yeah.
All right.
That, I guess a little bit of background about me for the listeners. I went to school for 4 years, studied politics, worked in politics for about 1.5 years afterwards. Hated politics after working in it for 1.5 years. And then bounced around and did some jobs that I just needed money. I just needed to work and didn't have much of a passion or a goal with my career for a while. And it took me a little while to come around on the renewable industry. And to be honest, when I took the solar job, when I found one in the renewable industry, I also didn't have a passion for it then.
That's okay.
Yeah.
Needing a job, needing to make some money, to work somewhere is common amongst most young people. It's okay that you don't have the answer on what you want to be when you grow up. And I think I told you probably after you graduated college what I wanted, when I figured it out, what I wanted to do when I grew up. That I haven't figured it out yet.
Yes.
I was
going to say, you never
That's right.
know.
That's right. So, you don't have to pressure people into knowing. It's okay. And maybe if I did, I apologize, but no, I don't.
Well, it worked out all right because turns out I'm not bad at it.
From politics to renewable energy.
A little bit of bartending in the middle, but it's a good greaser.
More than a little bit, if I remember.
Yeah, a little more than a little bit. Huntington Beach is pretty. What are you going to say?
Hard to leave that place. That was quite the beautiful spot.
Yeah, it's pretty expensive.
Yeah. Okay. So you didn't know, thought, okay, let's give this a try. So I don't know how long was it going before you started seeing a career path there for yourself?
In solar?
Or do you yet?
How long in solar until I started seeing?
Yeah, you're a 1-year solar technician.
Yeah, just hit
Right.
1 year. Today is the 16th. 2 weeks ago to date.
1 year and 2 weeks. And we're going to dig into what it's like being a first-year solar technician in a little bit. But tell us about that transition, because lots of people have to go through that or had gone through it or contemplating it.
Yeah, well, it was daunting. It was a lot. And I had no professional background. And electrical or even mechanical. But personally, I grew up working on cars and motorcycles and stuff in the house. So I knew a little bit, some basic DC stuff with cars and bikes, a little bit of AC with, maybe installing a ceiling fan at one point or something. I had no idea what I was really stepping into. And when I got to work, it was real OJT. It was fly by the seat of your pants. Here's day one. We're going to go check fuses. Follow me. Here's an amp clamp or a fork meter,
Right.
And I didn't know what I was doing. And how long did it take for me to like really see a career path? I had to start meeting some new people. I had to start making some new connections, and I really lucked out. My first month on the job, I got to travel to another site. I'm an O&M tech, so I have one home site. I got to travel to another site and work with another technician who's very senior and see another site, see some EPC project was still going on this site. And I got to see a little bit of a spread of, what is there to offer for jobs in this industry. And I was there for about 3 weeks. And by the end of it, I was done. I just went back to my site. I had such a better understanding, like, holy cow, there are a lot of jobs to do in this industry. And then I think that was maybe my first introduction to the possibility of other jobs, in this industry. And then I think the biggest stepping stone, the biggest leap that I took as I, walked down this new career path was my first stint at Rise. That was extremely eye-opening. Yeah.
That was what, 9 months in?
No. I
6 months?
I might get this wrong. Hope that not. I think it was May. So
5 months?
5 months in. Yeah.
Okay.
Yeah, maybe June.
And that was a pivotal moment.
Huge.
Why?
Huge. For the first time in my solar career, I was in a room with 12 other solar technicians. I'd never seen so many.
Okay.
Being an O&M tech, you're out there by yourself. I'm the guy that runs this site. It's a 30 megawatt site. It's a tiny site, so there's not a lot of guys. And it's the first time I was in a room with multiple people that did my job. And everybody came from different backgrounds, had different ambitions. Some of them did different jobs. Not everybody was O&M. We had people from our remote operations center there. We had people from our commissioning team on EPC. We had people that were specialized services technicians traveling. And that was super eye-opening. But not just the environment. It was also what Rise is doing. It was an entry-level, level 1 solar technician course. And that gave me, I don't know, such a good view of all the different routes you could go down. Learning about different OEMs for tracking systems, for inverters, for transformers, for everything that happens on these sites, how they're built, how they function, what the lifespan looks like. It was very, I got a clear picture and like scale of what's really going on here. And I got excited. I was like, I'm going to go home and work my butt off and try to get some new skills and grow and decide, maybe in a year's time where I want to go, all those different options.
All right. We're going to dig in, but just for fun, because you transitioned from, we'll say, politics to renewable energy. It's really bartending to renewable energy.
It's the best transitional phase for anybody listening out there. If you don't know what to do, hit the bar for a little bit.
You'll have to tell us if you can, name some cocktails after solar components or something.
Okay.
Come up with your own little scheme there. Or maybe it's got a Huntington Beach sort of feel or vibe to the names you come up with for solar parts.
High current cocktail.
Oh, look at this. What else you got?
Oh, don't put me on the spot. I don't know. I was messing with schematics today, so high current contactors were on the mind.
Okay. The H-bridge shot.
That's fun.
All right, not bad. We could do a PV blaster.
Yeah, I was thinking AC DC something, but that could be easily confused. DC AC, whatever.
Shaken or stirred. Okay, so you go out and you drove clearly across the country. We're in California. You drive to Virginia,
Yeah.
day one on a job, and you walk on a solar power plant. You'd never seen one before.
Right.
Didn't know what a combiner box was. Somebody says, follow me, we're checking fuses.
Right. I didn't know commonly referred in the solar industry, a table, right? A table is with the racking that the panel modules sit on and oscillate and face the sun. Everybody's talking about tables all day long. I didn't see a single table out there. I had no idea. I had no idea what was going on. It took me like a week.
Where are the tables?
Yeah. Yeah, no,
Why do we care?
I had no idea.
Okay, that's January 2024.
Yep.
Right now, it's January 2025.
Mm-hmm.
Give me 90 seconds, no more than 120 seconds, the synopsis of how the sun can power your house. Walk me through how a solar power plant works.
Didn't know it was going to be a quiz.
I know, but you're in school this week, so going to have to pick on you a little bit. Wouldn't be fair if I didn't.
All right. Well,
you can walk me through the components and how they work as you wish.
Well, I'll try to keep it truncated. I know people listening probably understand a little bit more than the average person, but
my point is you're a first-year tech, right? And I want to let people know, here's what a tech can go through from what's a table,
Okay. Yes.
What's a combiner box? What fuse? And 1 year later, tell us what you know now. Just 1 year.
Sure. Well, you look at a solar power plant, you can split it very easily into kind of two sections. Your PV DC field array and your power conversion system.
PV?
Sure.
What? No. What's the acronym?
Photovoltaic.
DC?
Direct current electricity.
Just,
It's a quiz, huh? It's a
No. One for, mom's watching too, right?
All right. Well, okay, you kind of have two parts here. Your PV DC array, so your photovoltaic direct current array, where you collect energy from the sun. Everybody's seen a solar panel, right? Mm-hmm. That's made of a few layers of some stuff I won't go into, but essentially what happens is the sun, the heat, the photons hit that panel and move electrons. And what the panel does with a set of diodes moves it in a certain direction. They collect the movement of those electrons. The movement of electrons is electricity, flow of electricity.
Where are those electrons? What's the medium? What's the current carrying conductor?
Inside a PV module?
Yeah.
You've got a P and N layer is what I know them as.
Okay.
I don't know exactly what's inside a module.
It's all right.
But in any case, well,
is that the table?
The modules sit on a table.
Okay.
Yes. Typically, some sites don't have tracking systems. I don't think you call fixed tilt tables.
Tableless.
Fixed tilt modules a table.
Oh, those poor modules. They got no table.
No, they don't move. They just sit there all day long, facing south.
Lonely.
Yeah. The other ones get to face east and west.
Wow. Privilege.
Yes.
We'd like to take this time to thank another one of our wonderful sponsors, Podge Engineering. Podge Engineering, making wind and solar all we know it can be. Are your renewable energy assets underperforming or not performing at all? Did you expect many years of longevity and they're failing on you now? Podge LLC offers many customized, engineered products and solutions to get these assets back on track. Podge Engineering also performs root cause analysis, engineering services, procurement, and construction. Visit podge.org. That's PADGE.org. Remember Podge, making wind and solar all we know it can be. All right.
Anyway, you collect some energy. Collect direct current energy from the sun. It moves in one direction. You combine it all into very high voltage. At your power conversion system, there is an inverter.
Mm-hmm.
Right? So I'm going to go a little deep.
Did we cover combiner box in a
No,
few
we
years?
didn't.
I heard that
skipped
somewhere.
over the combiner boxes.
I mean, that was just 1 year ago this
You
month.
said 90 seconds. All right. I'm trying to get to the substation. Well, so you got long rows. Mm-hmm. There's multiple circuits. You collect the energy in series. So you get the voltage kind of high. Usually 1,500 volts is a nominal voltage for most systems nowadays. Mm-hmm. They used to be 1,000. Before that, they used to be 600. Kind of much lower voltage, but now we do it a lot higher. Okay. Just advancements of technology. Then you run those all in parallel down to your combiner box. all of these, anywhere from like 4 to 25 or 30 strings of energy circuits come into one combiner box. Combine everything into some big old cables, run them to your inverter. At the inverter, you take all of that energy to an IGBT, which switches it super, super fast, changing the polarity of the direct current electricity. You're loving this, aren't you?
Keep going.
Turns it into alternating current. And then from there, you run it through to a medium voltage transformer. You step it way up, oftentimes 34,500 kilovolts, 34,500 volts, 34.5 kV. Pump that to the substation, and then from there, you get to flip on these fancy lights at your podcast studio.
Not bad. I heard IGBT. What's that stand for?
Insulated gate bipolar transistor.
What's that do?
You're killing me. I want to do the H. You want me to do the H?
Yeah,
For
well,
it helps. It takes your DC. This is conversion theory. This is electrical engineer shit. And you reverse the polarity. So in your H, you've got different polarities. I'll do the. It's easy. It's hard to explain.
All right.
A positive, negative, and that's a very rudimentary example. And you close and open your switches, right? Completing and opening your circuit many, many times, very, very fast, super high frequency, with super efficient switching, so you don't lose power in your switching. Most people probably know when you turn a light on, you use the most power because switching is very inefficient. When you turn your car on, you use the most gas. This is a very, very efficient form of switching. And when you do it very, very fast, many, many times, your direct current wave goes like this to positive and negative polarity because you're reversing the polarity. The faster you do it, it starts looking more like this. And then with a little bit of LC filtering with an inductor and a couple capacitors, that gets perfect to 60 hertz, 60 hertz sine wave just to go right to the grid.
Roller coaster to the grid.
That's right. That's right.
That's pretty good, kid.
Some person rides it, makes a lot of money.
Yep.
I just make it.
Better spot to be. Better spot to be. I can't believe you went in 1 year from looking for the table. Where's the table?
Took me forever to figure out the gate code. I don't know.
Right. And now you can explain power conversion from kinetic, mechanic, these transfers.
Not mechanic.
Not mechanic, you're right.
No, that's wind turbines.
That's right.
This is the only form of renewable energy that doesn't use a generator.
Say more. How's it work?
You asked me to explain what's inside a PV module again. I'm going to freak out.
That's all right. What you're saying is almost all power plants have to have a mechanical movement to create an electrical field.
Exactly.
That creates an electron movement.
Right. Free
electrons are moving, where there's no moving on a solar.
Right. That's what's happening.
So the heat makes the free electron move inside the current carrying conductor system.
Exactly. Yeah. Right. And this is just unique in that you move electrons differently. And almost all other power plants use this one style. And in solar, it's different. And for me, that's very exciting.
Okay. Why?
All it takes is a panel. You don't have to move anything. You don't have to have any sort of combustion or wind or steam or water to turn a thing. You just got to set a panel out and hook some conductors up to it. And then you got DC voltage.
Then you wait for the sun.
Yep.
That's it.
Sun's going to keep shining a lot longer than things are going to keep spinning.
Show up, flip-flops, board shorts, and sunglasses. Wow. Just like you're at Huntington Beach, and it works.
Don't tell NFPA and OSHA about it. But
That's pretty good, kid. That's pretty amazing. You've learned a lot about power plants, renewable power plants, very focused, solar power plants in 1 year. Do you ever think you'd know that much about a solar power plant?
No. In fact, I would have sworn that I would try not to.
I believe you did.
Yeah. Well, I grew up with you. I my whole life you were a renewables guy, and I just wanted to kind of make my own way,
Yep.
and got to a point where I needed a job, and my default skill set, which was taught to me by you, was kind of in some of these areas.
Yeah.
So,
Oh, so maybe growing up in a household or family that already works in renewable energy might have an advantage for the kids.
it did for me. Yeah, it did for me.
Yeah. I think it does for most. I just saw a post maybe a few weeks ago. I think it was on LinkedIn by Vestas, and they were telling a story, and it was like second generation, like father son. They're working on a solar or a power. It was a wind park. I can't remember, but the concept was talking about generations now following suit in this industry. It's got the age to it at this point.
It's starting to, yeah.
It's starting to. Well, clearly, here you are.
Yeah. Yeah, well, you can say it for wind, but not quite for solar, I think. That's got the age to it for generations.
Oh, fair.
But
fair.
obviously, some of the skills apply.
Yeah. All right. Well, let's talk to some technicians for a minute. You know what DC health management means, or maintenance? What's the word?
Yeah.
What's that all about?
It's making sure that you're operating efficiently in your DC field. So oftentimes that the entry level check that all of you technicians have probably done a million times is going around and checking for current flow during peak hours, good sun, good irradiance, checking for current flow on all of your strings.
If I'm a first year tech, is that something I'll be doing?
100%.
Okay.
Yeah, well, I mean, it depends on what you're doing, but yeah, I think if you're new, probably working O&M or side by side with somebody else, and that is definitely something you'll be doing.
Okay.
It's called DC Health, and it is a quick measurement of the health and efficiency of your entire site. Can't produce any power if you're not collecting it from the DC field. So typically it involves going around and checking with like a fork meter or an amp clamp just to see what the current is flowing through all of your strings. And from there you can identify problem areas. If you have no current flowing, you probably have a blown fuse, right?
That's a problem.
That's a problem. Yeah, you need that power. That's
Okay.
money on the table.
And this is this risky work?
Can be.
What kind of risks are there?
Well, if we're talking about a plant, PV plant that's operating at a DC nominal voltage of 1500 volts, assuming, well, let me backtrack. It can be risky work, but it's risky when you are operating around exposed electrical conductors. Right. Typically, to do this work, you're not. You're testing with some sort of safety device, like a fork meter or an amp clamp, something that goes around the conductor to test current flow. I use a fork meter. It's like this. And then I look on my little digital and it says what the amperage is. Is that a perfect measurement of your current? No. A more perfect measurement would be in line on the conductor itself. But that's not what I'm trying to do here. I'm trying to assess the health of my DC field. Is there current flowing? And there's a little bit of knowledge that comes with that. What's the nominal current of this string? Do you know what it should be? Never take a measurement if you don't know what it should be. It's a useless measurement. Anyway, back to your question. Typically,
It's a bit of a go, no go. Good or bad?
Sure.
Check.
Yeah, and we're checking it from a safe place. You're not within a restricted approach boundary to an exposed electrical conductor. I know there are some technicians that like to open up the combiner box and check right there at the string level. Totally appropriate if you're recognizing the arc flash hazard, wearing your PPE when you go within that approach boundary. For almost every setup, and not all of them, there's a lot of different OEMs and designs for sites, you can access the strings and test them elsewhere.
Okay. Might get you away from DC Health for a while. But
Thank you.
by the way, I think that could be one segment of the cocktail menu. This could be for your DC Health.
It's not bad.
It's not bad.
It's not bad.
What if all I know is mechanical, right? I'm a wrenches guy. I'm an oil and wrenches and grease guy. What kind of tasks might I see in my first year that would, relate more to me?
Well, we're creating electricity, but we have tracking single access trackers. It's the way that, let me back up a little bit. All of the modules are on a table, which we've discussed already.
Mm-hmm.
And, it's a long tube, and the table sits like this. And in the morning, they face the east, and the sun's rising. And as the sun goes through the day, they turn to the west like that.
So you got electric motors and pivot arms. And,
Exactly.
I don't know. Is there a worm gear drive of some type?
There are some, yeah. In fact, just today at Rise Training, we were studying single axis trackers, ironically. And there's one OEM, Game Change, who makes a worm gear drive actuator. This is the only one that I've seen that functions like that. But
there's a fixed drive.
no, it's got a gearbox attached.
Oh, I see. Just a ratio. Okay.
Yeah.
So look, I know gears.
Yeah.
I know nuts and bolts. I know how they should turn and pivot.
There's a little bit of work there.
Reaction arms.
Yeah, and there's suspension dampeners.
Mm-hmm. Probably got a lot of wires running around.
Yeah.
We got to take care of those.
Oh yeah, lots of wire management.
Wire management. There you go.
You're a first year tech. You're gonna zip tie a lot of freaking wires.
I was zip tie calibrator back in the day.
Were you?
I could just look at it and go, that one's bad. Throw it away.
Oh, I'm gonna have to start calibrating my zip ties because I think I got a lot more bad than I do.
You haven't had any break on you?
Almost exclusively, they break on me.
That's right. After a while, you better look at it and go out and throw it away.
Yeah, I need something else other than zip ties. Everybody's looking to go into the solar business. There's a good market right there. Get something better to hold those wires up.
This episode brought to you by RST Cranes. With over 30 years of experience, RST Cranes brings the industry expertise to every project. From wind turbines to solar inverters, mining operations to industrial construction, RST Cranes is your heavy lift specialist, located in Tehachapi, California, and serving the surrounding areas. Contact RST Cranes for your next project at www.rstcranes.com. And you said what we've heard before about, okay, I need a job, need to make a change, probably not for me. And then once you got started, you got to see all of the other jobs out there. This comes up so often on this podcast from our guests. It's hard for folks to see and know the career path. It's happening so fast. The industry's evolving so fast. So what's your career path look like to you now?
I'll tell you what, 6 months ago, it seemed a lot clearer. I don't know anymore. There's a lot of doors. There's a lot of forks off of this path. You're right. It comes up a lot. This is a very diverse industry.
Well, not knowing what options are available to you, so you can't pursue something, versus seeing so many options and not knowing which way to go. Two polar opposites.
Yeah.
You see all of the doors in front of you now, at least in this industry. And that's what I've been trying to get through to a lot of folks. Then you just take a look and decide which one you want to open. And kind of like how you weren't sure if this job was for you or this industry is for you, I always say, if you don't know which one, pick one.
Yeah.
You can't go wrong.
The worst decision is indecision.
That's right. Yeah. Make the decision or the decision will make you.
Right.
Yeah. Okay. I love it. I love that you're 1 year in and you've been seeing what so many of us have been talking about. All right. So if you could go back, would you make the same choice?
Yes. I would have made it 6 years sooner.
Is that right?
Yeah.
Oh.
I didn't, my degree's in political science and communications. I didn't need that to get this job. I could have gotten this job right out of high school, I think. Maybe there are some things I learned and some personable skills that help me with an interview here or there, but I would have skipped that whole process.
Fair enough. So similarities or contrasts between politics and solar power?
There's always people.
Okay.
Similarity, there's always people. And if you think that there's no politics involved in power generation, you got another thing coming.
Yeah.
Oh, yeah. Yeah, literal, U.S. government politics.
It's kind of hot right now.
Tariffs on parts coming from China.
Mm-hmm.
But also, or inverters coming from Germany or whatever. A lot of the stuff we use is not made here in the States. Some of it is, but not all of it. But not just literal politics. I mean, you deal with people. It's a massive industry. There's you have to be able. It's a business. We purchase parts and O&M. I work for somebody that owns the site to service their site. There's communications. It's not exactly politics, but you got to be able to deal with people. You got to be a personable person.
Right.
At some point or another, you provide a service or a product, or you purchase it, and you have to deal with people to do that.
Sure.
Yeah.
You probably have to deal with customers.
Yeah.
How's that going? What does the rhythm look like?
Well, on I've got one site that I manage, and I get involved with other sites kind of in my district usually. Just to help out here and there is how it started. Need another man for a safety second, cool. You need someone to help you lift a thing, cool. And then I help out with more stuff. And now I sit in on a lot of site owner meetings, asset managers.
Oh.
Particularly for mine, but then also for a couple others in the area, just because I'm often helping out and working on those sites. And well, how does it look? Usually it's somebody calling in once a week or once every 2 weeks, sometimes once a month, to go over hot topics on the site. How's it producing? Are we still working on closing out civil things? Or what's the spare parts list look like? What were the big issues this month? Did something fail? Did we do really well? And if so, why? It's those people spent a lot of money to build this site and produce power.
Right.
And they're paying me to take care of it.
Okay.
Yeah.
Powerful.
Feels powerful. You take a little bit of responsibility, right?
Some pride in that.
Yeah, exactly. Take a little bit of pride.
Some pride in that.
Show up to work every day trying to create a good product for someone.
I love that you said that. Show up to work. Yeah. Ready to tackle the day. All right, you have done way too good on the technical quiz. I was impressed.
The other solar guys out there might have messed up. I'm just a year one, all right?
I am a little upset. You told your instructor that I have an analog meter.
That was my favorite thing I think I told him.
That was your bet? Yeah, that was your favorite?
You made me use an analog meter. I think they're upset with you.
Well, they work just fine. All right. Well, maybe how about a key lesson learned from your first year as a solar tech?
Interesting. A key lesson learned.
You learned a lot.
Yeah.
But how about, when I say key lesson learned, maybe you did something, you learned the hard way plenty of times. What's a key one?
I think if I had a lesson that I learned this year that I could communicate to all the other technicians out there, whether they're new or tenured, I think it's so important that we all own safety. You've heard stop work authority, right? Of course, we all have. I think it should be more like, and I think I heard this from you or maybe a colleague, stop work responsibility.
Yeah, you heard that here, yeah.
Yeah, and I loved that because there are lots of renewables technicians out there, solar, wind, working on batteries, you name it. All of them come with hazards, dangerous work conditions. And a lot of people maybe don't realize it, or a lot of people, maybe minimize the hazards and unsafe conditions and difficulty in working on some stuff. People get stressed about pressure to produce from an owner or from their boss. And anyway, what the lesson I would communicate is, if you are working on a project or a task and you disagree with the job scope, with the steps, the procedure, or even don't understand, if you don't know exactly what's going to happen within your job scope, your procedure, if you don't understand because somebody else is leading, and this happens all the time, you're working crews, you may not be the lead, you may be the newest guy. If you don't understand and you think that there may be a hazard, call stop work. Talk about it. Revise the plan. That doesn't have to look like stopping work and hopping in the truck and going home for the day. It doesn't have to look like, writing a report against your crew lead. It can look like pulling your crew lead aside and saying, hey guys, hang on, I have a question.
Just time out.
Pause.
Just time out.
Yeah, time out. Why are we allowed to touch that bus bar right now? And then he'll explain it. Or he'll say, nobody verified that's dead? It could save someone's life. And there's nothing worth the few minutes it takes to clear something up.
All right. And so you probably witnessed this. I'm not going to have you call anybody out or anything you did, but I know darn well this happens a lot. I like what you're saying, and I think now you know what your responsibility is.
Oh, yeah.
Yeah.
It's mine. It's yours. If you're in the field with your team, you may not be climbing the tower and working on something, but if you see something, it's your responsibility to say it. It's everybody's.
Love it. Yeah. And it's just a timeout. It's just a timeout, and then it's game on.
People get scared.
Did you ever watch Wayne's World?
Growing up with you, yeah.
You saw Wayne's World?
I was young.
Just making sure. They're playing hockey in the street. Car. Okay, game on. Car, game on. It's just a timeout.
Yeah.
And then back to it, right? Then it's game on.
Yeah. Yeah, and it needs to be, it feels like taboo to call stop work. Like it's, all right, everybody has this authority, and there's a big old stop sign on every meeting.
Yell car.
Car. Fire. Don't yell fire.
Don't yell fire. That's not a good one.
No.
And then it's game on.
It feels so taboo, but yeah, if I could communicate to anybody, make it less taboo, make it a normal thing, understand the job, understand the task and what you're going to do, and then start working, get it done.
Okay. Think there's any generational aspect, approach, viewpoint to renewable energy, your generation to mine? Any differences, similarities?
Like, do I approach it differently than you? Well, I'll tell you what, looking at these wind turbines, I don't have a huge desire to climb one.
They got elevators now.
Yeah, so I hear.
About 3S?
I've heard about 3S.
They got them, we don't have that one up right now.
Oh, man.
You know what it is.
No, yeah. Yeah, well, no, I'd go up one of those. If it had a 3S lift, I'd go right up and take a cool picture, but I don't want to fix anything up there.
No?
I don't know. I would. I'm very fascinated in how it works, and I'd love to know it, but...
Well, why don't you? It just looks overwhelming? Do you think that's a whole generational thing? Your generation not interested?
It doesn't look overwhelming. I know how to turn a wrench.
Oh, why don't you want to go up there? Look at that so good.
Well, because I like solar more.
Oh, okay.
I think it's better, not for our lifetimes, but for 1,000 years from now. I think it's better.
Oh, interesting.
Yeah.
Okay. Solar over wind. We're going to have some division at the family Christmas get together. All right. I like it.
Some team t-shirts, maybe.
Yeah.
Less moving parts is better.
Interesting. I don't know about capacity per square foot when you're comparing the two, but
true.
Space is an issue. It's a big country, I guess. A lot of desert.
It's a big world.
We'll fill it up. A lot of rooftop. Could be.
I don't know about the rooftop gang.
No.
Not a big fan of. Not a huge fan of that.
Why not?
It's a hazard. Putting all that on my roof sounds dangerous. Having microinverters or a small small inverter on my wall or something. Sounds
Built ours at
hazardous.
the house in a week.
Yeah, that sounds scary to me.
All right. Well,
I'd rather put it in the... Listen, it's fine. And I know you did fine work and everybody else does. I'd rather just put a fixed tilt table in my backyard.
kind of thinking I need a house upgrade to my solar panel system I might assign to you.
A sign. My rates are going up.
Yeah, there you go. There you go. I love it. We'd like to thank our sponsor, Altair Energy Services, and their highly trained, expert technical staff, leveraging decades of renewable power management experience into customized solutions for everyone to meet their energy goals and contribute to a better future for all. Altair's team of hardworking, respected experts are providing full-scope, turnkey repairs, planned and unplanned maintenance, system upgrades, fully autonomous technical crews, supplemental staffing, and customized dynamic scheduling to fit your power production needs. Contact Altair at info@altairenergyservices.com and learn more about their wide range of capabilities across multiple power technologies and platforms. Okay, so nothing from your generation then outside of you that you hear, friends and things like that.
About renewables?
Yeah.
Very mixed reviews. And much like everything in this world, you either love it or hate it. A lot of people nowadays are so polarized on every single topic that could be discussed. So I know people that love renewable energy and I know people that hate it. And I think it's extremely obvious to a calm, logical thinker that you have to have a combination of all sources of energy.
Yeah.
And it's not figured out and perfect yet, but if we've got some good ones to use, let's use them and figure it out.
So have you looked into or have any thoughts on the evolution of solar for the next 5-10 years, since you love it so much?
I think it's going to explode, kind of like it has been for the past 10 to 15 years.
Yeah.
I think there's going to be, we all know that companies fall out of nowhere, right? In solar, right? Go obsolete. Now you can't get parts for this inverter. Just like that, new companies are going to form like crazy. New technologies are going to blow up like crazy. Is the photovoltaic technology going to increase? Probably not like crazy. It is a little bit.
Sure has.
Well, the efficiency rate is increasing, and that's a measurement of square surface area, and so the efficiency of modules.
More watts per cube linear space, right?
More watts per surface area, more power.
There you go.
That's an efficiency rating, and a lot of that can increase a lot, right? But I don't think the technology is going to change, right? You follow?
But you think it's going to grow and be a major player to reshape the grid of the planet?
I think it's got huge potential. Yeah, I think the power we produce today is going to grow by a massive factor, and I won't quote any because I don't know those numbers, but yeah, I think it's going to play a huge difference.
What happens when the sun's not shining?
You got to store that energy somehow.
Oh, does battery come into play?
Certainly starting to, yeah. I shouldn't say starting to, it has been, but it's starting to get much bigger, starting to explode. A lot of new site constructions are having battery built into them. BESS stations, battery storage.
Yep. No, if you don't put a battery with solar, it's like having peanut butter, no jelly on your sandwich. It's just
a solar battery sandwich.
It's not going to work.
No, it's a lot of new sites are being built with them, engineered that way, and a lot of existing sites, legacy sites, are having them installed.
That's right.
Yeah, and that's from what I understand, a heck of a job. I haven't been involved in much of that, but
a heck of a job.
Retrofitting.
Oh, I see.
Your already buried lines to have battery storage. Still have yet to go over my BESS 201, my advanced BESS training with RISE, but
I see.
You need converters, DC to DC converters. You store the energy in DC, and there's a lot going on there. So you gotta
Yeah.
Retrofitting
figure
an
it out.
existing site's a lot.
You understand how they can switch back and forth, and then
Oh yeah, of course.
your teacher just asked me what voltage or what type of current is present in the capacitor when you disconnect the
I
supply.
just heard
Do
this.
you have this answer?
Of course. What type of electricity is present in
Is
the
it AC or
capacitor?
DC?
It's always DC.
All right.
Where's it
Tried to
going?
get me on that one the
It's
other
not
day.
flowing inside that capacitor. Where's it going?
Any favorite technologies, OEM, inverter, panel, tracking system that you've worked with? You got some favorites?
Well, I can't claim to have seen all of them. I work a lot with the FTC solar tracking system. It's a individual node, we call it a row controller that communicates to a master controller.
Mm-hmm.
I think it's pretty rad. I also really like the gearbox and motor system for turning the tables. A slew drive is what it's called.
Mm-hmm.
I think it's a little bit better than some of the game change actuators. I'm a little biased towards them. Sorry.
Hey, how about panels?
How about panels?
Yeah, you have any favorites? OEM?
No, I don't know a favorite OEM for modules. No, everybody and their sister's making modules. I don't.
Inverters?
Yeah, I work mostly with T-Mic Ninjas, 840 kilowatt units. They're pretty easy to work on. They're small units. I know everything about them now. I might say they're my favorite just because I know I can easily troubleshoot and replace something in there. But I have had the privilege to work on a couple of SMA K1s, the Kodiak, new Kodiak.
Okay.
Those things are Cadillacs. The DC and the AC are separated by front and back. There's a recombiner right there in the front of the DC side. Very intuitive HMI screen and interface with fault codes and monitoring right there on the side. It's like an iPad. I don't know if you've ever seen one of these.
No.
If you get a chance, it's very cool.
Huh.
Yeah, they're very neat.
Hit any string inverters ever?
The only string
They're
inverter
not being used very much anymore, I don't think.
Did you ask Steven San Juan about string inverters at all?
No.
He doesn't believe that string inverters exist.
They don't exist.
It's either a micro inverter or a small central inverter.
Okay.
But no, I've worked with Chint a little bit up in upstate New York. It's actually, I think, about 35 megawatts of power all coming from these Chint string inverters. I think oh man, I'm gonna misquote this. Maybe somewhere between 200 and 300 kilowatts.
Okay.
I could be wrong.
So you've seen some.
Yeah,
I've
actually replaced two of them.
Okay.
They're like 150 pounds, whole inverter. You just plug and play.
Plug and play.
The plug and play design by those guys was pretty cool.
Okay.
That was pretty fun.
Nice.
Swapping out an inverter in like 30 minutes. That was crazy.
Yeah, that's slick. Except there's a lot of them.
A ton. They're on this stupid racking system. Just a bunch. They look like combiner boxes.
Right.
Yeah, it's kind of silly.
That's right. Let's thank our friends over at Renew Safety, your proactive partner in safety solutions. With comprehensive safety consulting, ensuring compliance with all safety regulations and standards. Expert staffing solutions, providing trained safety professionals tailored to your project's needs. Commitment to sustainability, promoting a safe and sustainable working environment. Contact Renew Safety at info@renewsafety.com and speak to one of their industry experts about their proven track record for safety management on numerous projects. Or perhaps you're looking for construction safety staffing, contractor monitoring, incident investigation, or program development and training. Check out Renew Safety at renewsafety.com. You're a tougher interview for me, kid. I know too much about you. It's not fair. Well, what are your top priorities and goals as you move into your second year?
Significantly increased exposure to the industry. I want to meet more people. I want to learn more power conversion system, inverters, and tracking systems. I want to see other sites. I want to obtain a wealth of knowledge about this industry. I'm 26, almost 27. I don't want to be in the field forever. So I want to maximize my time in the field. My first year, I think, has been an overload of knowledge, and I love it.
Good.
I don't know, got very lucky. I was a man who needed a job, who found a job, and I happened to love it.
Because you heard what happened to the man looking for a job.
He went out and found one.
That's right.
Yeah, if you look hard enough, there's one out there. Anyway, I found one. I became passionate about it. I learned a lot, and I think in 1 year, I feel like I'm good enough to learn more. I get to keep going, hit a little milestone.
Good.
Save my progress, And year 2, I want to grow on that at a faster rate, and I think that requires surrounding myself with people smarter than me, and with systems and equipment that I don't know about yet. Challenging, right? Challenge myself and grow more and do more. And yeah, I don't have a good metric for it yet.
No.
What I want out of my second year, but
you're going to continue to focus on the technology. You want to see more of it, different types.
Yeah,
that's a great goal. That's a great goal.
Yeah, and I find myself recently learning more about the electrical engineering stuff. I can't get away from the electrical theory talk. So there may be some supplemental, information, some classes maybe in this second year. I've thought about it a little bit, and that kind of excites me. I don't think I want to go into engineering of, inverters or something, but I'm just very passionate about it. I like learning about the stuff. I like talking about it.
Someday I got to introduce you to my friend Joe.
I know. I think he's out near me. I think maybe East Coast.
I heard he was up in Washington last week, but that man travels around helping everybody. One side at a time.
I've listened to him on the show, and he's a very smart man.
Yeah, someday you have to meet him. You'd like that.
Yeah, that'd be excellent.
I think it's perfect. Second year's got to be about the technology. Continue to grow that knowledge and education, that skill set. Really know the product, know the pieces.
Yeah.
Know the sites and sizes and the components and the OEMs.
I'd like to get a couple of OEM-specific certifications under my belt this year. I think that'd be cool. Some of the inverters that I've spent my time working on, maybe T-Mic, maybe SMA, maybe other ones. I've touched a couple of ingot teams, touched a couple of string inverters. I don't really care about getting a certification for them, but
Sure.
There's definitely that would be a cool area to grow. Be a certified technician for some of those. And I already know a lot of them. I just got to go learn from the best, and yeah. And then I think, maybe 5 years, get out of the field, become as good as I can, and then get out.
I only asked for the second year goal. No need to think past that right now.
Yeah.
That's a great goal. Yeah, I think it's spot on. And I love that you went from not sure if this is for me, actually it probably isn't, to wow, there's a career, there's path, to I love solar. And now my second year is how much more can I learn about it?
Yeah.
Very cool.
It's a crazy path. I wouldn't have guessed it, but took a shot. And, made a choice and fought for it. And if it's going to be the wrong choice, I'm going to know it was the wrong choice. And so far it hasn't been. So
that's perfect.
Yeah.
And then you can cruise back down to Huntington with your new bar menu, your cocktail list.
Yes.
We have our for your DC health and for your power needs. I don't know what it is. Give me something. The H-bridge bomb.
Yeah, maybe the switchgear shot or something.
Ooh, not bad. Yep. All right, we'll keep working on that. But I get it. Lots, you're not different than a lot of people in their 20s. Not sure where to go. Pretty sure don't want to follow that path. Pretty sure I want to do something on my own. Pretty sure partying's fun. Huntington's cool. I get it. It happens. And it happens to so many, and it's okay. It's okay. It's sometimes the right path. And I think there's a lot of young people out there, similar stories, and you've got a cool one. So then you had to go and get your resume up and get it out there to a whole lot of companies. And sometimes you can go to a school and they'll get your resume into 90 companies in a week. You hit a school and they'll really help you. Hell, I couldn't get it in front of 90 companies, So these schools and institutes and training companies out there, or institutes rather, they're beneficial for that, to get a little bit of knowledge and your resume out and interview.
Yeah.
So you did a different way, but you went and interviewed with a bunch of companies and you got a great job.
Yeah. Yeah. Honestly, sometimes I still think about some of those schools, but then I realize I'm kind of going to the best one. Right
You
now.
are going to the best one.
Yeah. Rise is solar. And those guys are smarter than anybody that I've ever met in this industry. And
they're going to hear this, so.
Well, my point is I can never tire of asking them questions. So
yeah,
I'm gonna keep asking.
Yep.
And yeah, I think I say I would have liked to make this career choice earlier in my life. Of course, more time, because I found it and I like it and I'm learning and becoming good at it. But I don't think I would have been able to do that if it wasn't when it happened. I had to go try some things. I thought I was right. Thought I was going to love it. And then, I needed to flounder for a bit and kind of fell on my face. And then, found the humility to come and join the industry my dad was in. And who knew it was going to work out so good?
I would just like you to let your mother know that it was okay for me to let you fall on your face.
Yes. No, it might have been the best thing that ever happened to me.
Oh, Mom's got to watch this one. Got to. Okay. So just to help others, young folks in techs maybe, or people wanting to think about getting into it, get the resume out. Technical institutes are great. Networking with your friends, get your resume updated. Did you have to prep for the interviews? You're damn right you did.
Yeah.
What did the interview prep look like? Because you can't fake that. That's the other really big part of getting the job you want, the first job, the promotion. You have to prep for the interviews.
Yeah, of
don't
course.
you?
Well, there's not an interview in the world that someone shouldn't prep for.
Right.
If you're out there going into an interview blind, why are you even going?
Yeah, that's strike 3.
Yeah. Do you want the job? I had to prep. And it was mostly because I felt very self-conscious about my knowledge of electricity.
Well, that helps. Humility helps.
Yeah. And I mean, when I got my first interview, it was like a shit your pants moment. I was like, oh, dang. All right, let's go to YouTube, right? And I went to YouTube. I think it's is it Engineering Mindset and Electrician University. Well, maybe I don't know, shout out for those channels if I got them right, but something like that. Some really good electrical theory stuff. And I even found a couple little videos about day in the life of a utility solar technician. And I brushed up and I prepped my butt off because, like I said, I fell on my face before this and I needed a job. So I made sure I was going to get it. I probably did too much, but, I learned basic stuff. At this point, what is AC? What is DC? How are they different? What is an electron? How do you generate power? I mean, like volts times amps equals power, right? I'm studying.
No, give us the floor. What's the formula?
I'm studying basic electrical theory formulas,
Sure.
And I remember this is interesting. You asked me after I studied a bunch of these videos and took notes like I was in 7th grade science class again. And I was about to go in and you asked me if I knew what continuity was. Do you remember this?
No.
You asked me if I knew what continuity was. I said, no. And you told me it's checking for a closed circuit, for a break in a circuit, right? And I was like, so I jotted it down and I go and I have my interview and, I get through the personnel part of it. And then we get to the part where they quiz me a little bit and ask me some questions, my first interview. And I shit you not, one of the questions was, do you know how to test for continuity?
No kidding.
And I was like, yeah, with a digital multimeter, and it should beep, right? You know?
Should beep. Beeps are good.
Beeps are good. Very, very low resistance.
Yeah.
Is better.
It's hard work to prep for an interview. It's hard work to prep for any interview in life.
Yeah.
And you got to do research. You got to do your homework. You got to talk to people, have folks challenge you, ask you questions. And it doesn't matter what the job is or the industry is. You got to prep for it and you got to want it.
Yeah.
And you got to have a reason. And I know this is funny, you know, needing a job and not having a job is a great reason to go get one.
Yeah, 100%.
Right? That's the old family joke. Do you know what happened to the guy that went looking for a job? He found one.
You found one.
But at the interview, that can't be the answer. Just interview 101. That's not the answer. The answer needs to be, what is your desire for that company and for that position?
What value would you provide?
What value do you provide? What value does it provide you?
Yeah.
Right? Well, here's what this job means to me. Here's how it'll affect me. Here's, what I believe I can do for you. Real answers.
Yourself.
Like, I just need a paycheck.
Oh.
Not going to work. Not going to work. Yeah. Gas went up. Baby mama's pissed.
Eggs are $10 a carton. Can't pay rent in San Diego anymore.
All right. Well, any final thoughts you want to leave for your father and the podcast?
Well, thank you very much for having me on. I wasn't sure if you guys were gonna get much from hearing from a 1-year technician. I hope you did. It was very fun. Yeah, thank you very much for having me on. And the studio's looking rad. I get to sign the banner.
You get to sign the banner. You did the podcast.
Heck yeah. Maybe one little thought. You need some pictures of solar up here. Where you got all these wind turbines. There's no solar panels.
Oh,
Come on.
hook us up.
All right.
I don't have any. Hook us up.
I got 1 million on my phone.
All right.
You want a couple of those?
Hook us. Yeah. Whichever one you think is going to look good.
I'll find you a good one.
Hook us up. That's fair enough. And I appreciate you having the courage to come and do it. I know you get a little bit of an advantage because you're my son, but I understand how nerve-wracking it can be to do a podcast and from a first-year technician perspective. But I'm hoping it encourages other first-year, fourth-year, fifth-year technicians even to come in here and talk to us and tell us what it's like, a day in the life.
Yeah, I've had a year and I'm still learning.
Yeah.
Got a lot more years in front of me.
Appreciate it, kid. You're doing great. Keep it up.
Yeah, thanks. You too. You're doing great.
Oh, thanks, son.
Keep it up.
Adios.